Hey everyone, welcome. Today we're tackling a Leetcode problem called triangle. It's a classic dynamic programming problem, and we're going to break it down step by step so it makes perfect sense. Don't worry, we'll cover everything from understanding the problem to the solution. Alright, let's dive into what this problem is asking us to do. We're given a triangle array, and our goal is to find the minimum path sum from the top of this triangle all the way down to the bottom. So we're starting at the very top number. Now, here are the rules for how we can move. From any number, we can only move to an adjacent number in the row directly below it. More specifically, if you're at an index I in your current row, you can move either to index I or to index I plus 1 in the row right beneath it. This means you can't just jump anywhere, you're pretty restricted in your choices, and we want the smallest sum possible through this path. Let's walk through an example to really see this in action. The input is this triangle of numbers. Our output should be 11. How do we get that? Well, starting from the 2 at the top, we can go to 3 or 4 stack lengths. If we pick 3, then from 3, we can go to 6 or 5. If we pick 5, then from 5 we can go to 1 or 8. Choosing 1 gives us 2 plus 3 plus 5 plus 1, which sums up to 11. That path is highlighted in the explanation as the minimum. We need to figure out how to find that minimum path systematically. Just a quick look at the constraints. The triangle won't be empty, and it won't be super huge either. Up to 200 rows. The top row always has just one number. Each subsequent row has one more number than the row above it, which makes sense for a triangle shape. And the numbers themselves can be negative, which is important. This means a larger number might actually be part of a smaller overall sum if other parts of the path are very negative. Okay, let's talk about the first approach, which is a classic dynamic programming solution, often called bottom-up. The core idea here is to start from the bottom of the triangle and work our way up to the top. For each number in the second to last row, we look at the two numbers directly below it in the final row. We pick the smaller of those two numbers, and we add it to our current number. We essentially replace our current number with this updated minimum sum. We keep doing this, propagating these minimum sums upwards, until we reach the very top. The intuition behind this bottom-up approach is quite clever. If we tried to go from top to bottom, we'd have to make decisions at each step, and we'd end up recalculating the minimum path for many subproblems multiple times. That's not efficient. But if we start from the second to last row, say at a number x, we know that to get from x to the bottom, we must go through one of its two children in the row below. Since we want the minimum sum, we should clearly choose the child that has the smallest path sum from itself to the bottom. If we've already processed the last row, then we know the minimum path sum starting from those children. So, we can update x to be x, plus the minimum of its two children's already calculated minimum paths. We do this all the way up. By the time we reach the very top of the triangle, the single number there will hold the minimum total path sum from top to bottom. Alright, here's the Python code for our bottom-up dynamic programming approach. It's quite concise actually. Let's break it down. First, we figure out n, which is just the number of rows in our triangle. The outer loop, for r in range n-2 to -1, stepping by -1, is crucial. This loop makes us start from the second to last row, all the way up to the very first row, which is row 0. We're iterating backwards through the rows. The inner loop, for c in range length of triangle at r, goes through each number in our current row r. And here's the magic line. Triangle at r at c plus equals the minimum of triangle at r plus 1 at c, and triangle at r plus 1 at c plus 1. This is where we update our current number. We take the current number, and we add to it the smaller of its two children's values from the row directly below. Remember, those children's values have already been updated to represent their minimum paths to the bottom. After both loops finish, the very top element of our triangle at 0, will hold the total minimum path sum from top to bottom. We just return that.